Alright, good day guys, how are you all doing? We're talking about solving a particular certain equation by what we call an iterative method. So one of the one that actually captures my view is the Newton-Raphson method, which people usually call the Newton method. So at times it's actually impossible to determine like the exact root for some certain particular equation. So in those kind of case, an approximate value can actually be found using what we call a numerical method. And like I said, the popularly known one is actually the Newton method. It's very much more easier and a little bit specific. And why is it telling us that? It says when a particular certain values could not develop an exact truth, there are some certain similar points. Don't worry, I will break down the definition with the graph aspect of it, and also if you could actually prove the formula. But literally, we're not proving now. We are only explaining some one or two things to ourselves. So it tells us that there's a particular certain point, like a midpoint, at which all the value converges together. And in that point, that shows us that even though there are some values that are closer, there's an estimate of where it will get to as a closed value. So in that point, that is what Newton helped us to in discovering. So, and also you need to note some one or two things also. The first rule to actually carry out Newton is that we know that it deals with a function of x. Let's put it that way. So the first thing that you have to what select an estimate of the root. That means you are looking for like at least we call it this s naught, like a basic value that okay literally this s could start from this certain particular point before we now start what evaluating. So we explain this one also in our example. So the second thing is that you differentiate the particular function you are being given. Are you getting what I'm saying? So the third thing that we want to talk about, and also after you are differentiating certain particular function by breaking it down from the y equals to the function x naught plus differentiating the what, the x naught times what, the normal variable minus the what. That's like a next value, just like you saying a change in the what, in the variable. So we want an estimate of x when what, when y is equals to 0. That's when your y, which is the function x, is equals to 0. So what do we now do and how do we carry it out? So from this point now in space, then if you look at this, you would see that what we have to, when we set y equals to 0, the differential formula cannot be manipulated algebraically, which I'm still going to explain with the graph, but literally just need the formula mainly. So in that point now, we can say that what x can be equals to x naught minus what, the function of the x naught over what, differentiating the function of the x naught. So if the value of x is actually just saying that normally x1, that means that we can say that what, the value of the root that we want to get can be equals to what, x1 being equals to x naught minus what, the function of x naught over differentiating the function of s naught. So to make it much more clear, because we keep testing for each value, you can say starting from x equals to 0, from x equals to 1, x equals to 2, it gives us different solution to our problem. Then we check out which one is up to scale. So you repeat the process you get to get subsequent value of x. So in that point you can say that what, we have to put it in a sequential then, that by saying what, the function of x, since it takes x1, x2, x3, we can just say what, let it be xn. So xn will be equals to what, whatever has to be here has to be lower than whatever is here, just like the first one. Now I'm not talking about in values, I'm talking about the first value. This is like next value, so it will be like the next value minus what, the lower value, to get whatever you are dealing with. So xn, if this is 1 now, you should know that this will be equals to what, x naught, or we say x0 minus the function of the xn minus 1 over differentiating the function of the xn minus 1. So we continue this step until what, a sequence, like I said, converges. You get what we call the value are getting closer, just like also under limits. You know that when you actually limit a particular certain value, we need to get a real value, but literally that real value you get is just like we're saying converging. That's why at some certain particular point of time, some limit does not exist. So until a successive estimate round to the what, to the sum of the value is what, is determined by what, by our accuracy. So let's check out a certain example under this and how we do manipulate things under it. Alright, so let's check out a certain particular example under Newton-Raphson method. So it says use Newton method to determine the positive root of the quadratic equation. So from this aspect of view, we have 5x squared plus 11x minus what, minus 17. And just like we said, at times they might give you what we call the x naught, and at times you might be forced to find it yourself. And we have to start with some certain values by what, utilizing starting from 1 to 2 to 3 to check out some certain variables. And we know from here this is a function of x being equals to 5x squared plus 11x minus what? 17. So we keep testing from each category. So we check from f equals to 0. So at this point of f equals to 0, you are going to be having minus what? 17. This becomes 0, this becomes 0. So you test from f equals to 1. At the point of f equals to 1, you have this 5, this is plus what? Plus 11. That should give you what? 16, right? And 16 minus 17. That should give 1, you have 5, then 1 also. This gives you what? 16, like I said. Then 16 minus 17, you have what? A negative 1. So if you have to test further f into 2, this should give us, you have 4 times 5, you have 20. Then you have 20 plus 22, which gives us 42. Then minus your 17 there, you are going to be having what? 25. So from this particular aspect of view, when we want to check out some one or two things under it, how do we know the value we have to pick is what I want to actually explain better. So coming, sorry please, a minute. 20 plus 22 minus 17, so you have 25. So at this particular point, you should know that on the x-axis a particular value could vary, and it moves from the positive x-axis going down to the negative x-axis. So at that particular certain point, that shows that it has actually crosses a certain particular value or a certain particular answer, which is that of this particular expected equation. But we can't easily know exactly, but we know that since it has crosses the positive to negative, that means that the answer we are dealing with could be intermediate between these particular 2 points or these two values. So we can easily decide that what the answers we are dealing with could be between 1 and what? And 2. Are you getting what I'm saying? That why I use it is interval between 1 and 2. That means is that 1.5 or you have 0.5, literally, or you have 1.5, 1.6, 1.7. It can be 2 itself. Are you getting what I'm saying? So at this particular aspect, I'm trying to check out for Duster. So sorry. So at this particular aspect, you need to think rationally. And how do you think rationally is that? Since I know that this is between 1 and 2, then I have to test. There's something I want to tell you guys that you need to put note of is that whenever you are differentiating your function xn minus 1, it cannot be equals to 0. That's the function you are being given. It cannot be equals to 0. So since our value is between 1 and 2, which one do you think we can utilize? Now from there, let us differentiate the function first. Then we insert 1 into it to see, or we insert 2 into it to see which one we can utilize as what we call our s naught. So this is based on what we call an intermediate value. An intermediate value theorem. So from here we have 1 and 2. Then we want to differentiate the certain function. So differentiate the function x. This becomes what? You have 10x plus what? Plus 11. And if I'm to insert, differentiating this function, if I'm to insert 1 into this function, I have what? Minus 7, so that becomes 0. Now to insert 1 into this particular function, I have 10 plus what? 11, which gives me what? 22. Right? And from this aspect of view, again, if I'm to insert 2 into the particular function, I have what? 20 plus what? 11, which gives me what? 44. Which means that both of them are actually what? Suitable, or they are both useful to what? To utilize. So from this aspect, I can decide to say, okay, let me use what? Let me use the function 1. So if I'm to take my s naught, my intermediate value, starting from what? Starting from 1. That means that my s naught is from 1, and to get my s1, that will be equals to what? S1 minus 1, you have 0, which is s naught. That will be s naught minus differentiating minus the function of what? S naught over differentiating the function of what? S naught. Are you with me? So from this aspect now, our x1 would be equals to, what is the value for x naught? You have 1. So that will be 1 minus the function of x naught. When you insert 1, it gives us what? A negative 1. Do not forget, this is the function of the x naught when you insert x naught being 1. When you insert negative, when you have 1, when you insert 1, you have negative 1. So you have minus into bracket negative 1 over the way you differentiate the function of x naught. That's by inserting 1. What do we have? We have 22. So from there you have x1 being equals to 1 plus 1 over 22. And when we are to calculate this, you have 1 plus 1 over 22. That gives us is 1.045. That's approximately. Then we test on again to check out for x2, because you can't just stop at one value and you assume that that is your answer. You have to look at a point whereby a particular certain two value converges. So let's assume you have x1 as 1.045, you have x2 as 1.345, you have s3 as 1.345. That means that s2 and s3 actually what converges. That means the solution to the answers or the equation you're dealing with will surely be what? Be that certain particular value. So we've checked for x1. So let's check out for x2. So at the point you have x2 being equals to, that would be what? 2 minus 1, which would be what? The value of x1, right? Minus the function of x1 over differentiating the function of what? Of x1. Do not forget that you have to become to what? To break down some certain things. So from this aspect of view, we have this. Our x2 now will be equals to, now when we need to find the function of x1. What is x1? 1.045. The function of x1 inside this function and the function of x1, why it is being differentiated. So from this point, the function of x1 would be, because that means anywhere you are to see x1, you insert 1.045, and that would be 5 into brackets 1.045 square plus 11 into bracket 1.045 minus what? 17. Are you get what I'm saying? Minus 17. So from the other aspect again, this should give us, I'm coming please, into bracket square times 5, then plus 11, you have into bracket 1.045, so then minus 17. So that gives us a negative 0.0401. So the function of x1, why it has been differentiated, that would be just ordinary 10 into bracket 1.045 plus 11. So 10 into bracket 1.045 should give us 10.45. Then plus 11, you have this to be equals to what? 21.45. So while finding our x2 now, that will be equals to your x1, which is 1 point, our answer for x1 is 1.045 minus into brackets minus our function of x1 is what? 0.0401, then divided by the differentiation of it, which is 21.45. So our x2 would be equals to, you have this, is 0.040, 0.040 divided by 21.45. So that gives us this. Then 1.045 plus the answer, that gives us approximately 1.046. So, and the question tells us to 3 significant figures. So this also can actually be approximately equals to 1.05. And since this first equation is actually 1.045, it can also be approximately breaking down into what? 1.05. Do not forget. That means that what? Since x1 is also equals to x2, that means the positive solution for this particular question using Newton-Raphson's method would be x1 since equals to x2 equals to what? 1.045, or approximately 1. Now approximately to our 3 significant figure, you can't have 1.045. That would be what? 1.05. So that is the answer to that for this. Thank you.